But no, so I want to have, so I guess by way of introduction, Igal, I mean, he's done very many illustrious things in his past, but I think the most ZIO related things are he is the author of ZIO IntelliJ. So if you are using IntelliJ for doing your stuff in Scala, which there are some pretty strong arguments for doing, and you're doing stuff with ZIO, then you should definitely be using that plugin. In addition to that, I think he's just been kind of an active contributor to the community over time. I think really kind of sometimes a gadfly in a very positive way of kind of raising like, hey, this thing feels a little awkward. How can we do this better? I think he's helped out on test containers at various points in time, come to all sorts of hackathons. So I've had the pleasure of getting to know him. But today, the reason I want to have him on in particular is he's developed a new tool called ZIO Clippy that I'll try not to steal all his fire. It basically gives you better error messages. And yeah. I want to have him on, one, just to kind of show you the tool and to promote it, because I think it's like really useful to you. And if you're not already using it, you should be checking it out. But two, I thought it was a pretty cool example of something that, like, I think when we get into it, and I think I'll tell you this, is like pretty simple, but if it was so simple, why didn't anyone do it before? And so I think it could be a little bit of a cool opportunity to kind of discuss how he came up with the idea and how he implemented it, and just, I guess, get everyone's own creative juices flowing for things that they may do. But yeah, that's enough of me talking. Let me hand it over to you.
Thank you, Adam, very much for the introduction. I'm really excited to be here. So, wow, where do I even start? So let's start with Clippy and kind of maybe work backwards. So one of the things that I do at my work is other than making sure that, you know, we're in the air and doing everything else, more or less, I oftentimes mentor newcomers. And one of the last remaining kind of things that ZIO is kind of may intimidate newcomers is that the error messages, in particular the type mismatch error messages, when they happen, they might be very long, and it takes a lot of practice to read and understand them correctly. I will demonstrate some of those things shortly, because Scala does not really give you a way to customize those error messages. If it fails to mismatch your type, then you will get the short version, the long version, which is too long sometimes, and then you kind of have to train yourself to, what we usually do is we copy paste the message to some text editor on the side, split everything by commas, try to remove duplicates, because we usually like to look at the expanded version of the environment, and then mentally try to remove the things that are being provided by the environment, by Zenv. In particular, I do want to mention that most of this pain comes from the fact that we're still using ZIO 1 at work. And so most of this is kind of relates to the fact that when we started early on with using ZIO at our company, it was still in the ZIO 1 was still in the release candidate stages. So we're very early adopters of ZIO. And what we end up using is what we knew how to use, what was the most recommended way to do stuff, which was to use the environment to its maximum extent. So our very early kind of major services at our company are still kind of written in this ZIO 1 style, where everything is more or less propagated on the R parameter on the environment, which was also the topic of my talk at ZIO World. And we're gradually moving away from that. So most of the new services are written in the ZIO 2 style, in the service pattern. So dependencies are hidden in the implementations, but there are still cases where the environment is being heavily used. And over time, it grew from 3 to 4 to 5 services to sometimes having 20, if not more, because all of these kind of, we call them now implementation details, but all of these implementation details have to be propagated on the R. There's no way to kind of eliminate that. And when type mismatches occur, they take half a screen. All right. So my idea was always, how can I improve this? So I knew that particularly nothing could be done about this. So I just kind of casually on Discord asked I wish there was a way to kind of customize Scala's error messages. And then Rob Walsh, one of the members of the Spartan program, he kindly pointed me to the fact that Enzyme, the language server that Sam Halliday developed, is doing some stuff to kind of override or intercept the error reporting in Scala. And it does it, and Enzyme does this for both Scala 2 and Scala 3. And this was an amazing thing for me because this already gave me an entry point into something that I can actually look to see how it works. And it ended up being in the end, it ended up being very, very simple. So other than me just talking, let me just share my screen and try to first show everyone what the problem is and what the solution is and how it actually works. So I'm going to share my screen right now. So first of all, this is currently the landing page of Enzyme, which is the Enzyme the next generation, and it's not on GitHub, unfortunately, but there's a link to the source code in a tar which you can get and poke around in it because it's really great. Sam, like I said, standing on shoulders of giants, Sam has been doing Scala, has been doing crazy stuff that relates to compiler plugins, etc., for a very long time. So everything there is really nicely factored and ready for for consumption and adoption. And he's a big believer in free software, so everything can be used for in open terms. But just to show you the problem, I'll just going to go quickly to I have a project called ZIO Playground, which is a ZIO 1 project still. But it kind of demonstrates the problem. So just if it so happens that you have a mismatch of the thing that you declare or the thing that Scala infers the signature to be and the actual thing that is expected, when you try to compile it, you will meet with this error. Now, this is no fun to look. This is a very small kind of a small.
I was saying it's still very simple. Yeah.
Yeah, it's a very deliberate error. But what happens is I just want to make sure that there are kind of two parts here. The found and the required. So the found is what Scala found, what it found to be defined or declared here. Okay. Then it expands it. So it takes all of the type aliases. For example, console is a type alias. So it tries to de-alias it. Now, if you happen to use, if I were to specify console twice here for some reason, or maybe specify with ZENV or something like that, it would repeat all of the services many, many, many times because it does not do any deduplication. All right. So you might find, so here, for example, it says, this is what I'm expecting because the type signature here says, give me a URIO of ZENV. So it says, I'm expecting in the expanded form, a ZIO that has all of these ZIO services, right? In addition to, nothing, basically. Anyway, this is something that many people see throughout the day. And this is something that cannot be really helped by use of macros, as far as I know, because this is an actual compilation error that the Scala compiler will emit in case it finds a type mismatch error. I know that there are some improvements in ZIO 2. We might maybe talk about this a little bit in a little bit, but let me just show you what the plugin does. So the Scala, the compiler plugin, the ZIO Clippy, funny name, is when you add it, okay? And I have to reload the project. I'm using BSP for this. But now if I go and try to rebuild the project, I'm going to get something that's nicer. This was very much inspired by Kit's work on ZIO Magic and the ZIO 2 style of error reporting. But what it ends up doing is it ends up taking the original error message, trying to figure out the list of the expected and the required dependencies, put them in a set so that to deduplicate them, all right? And just give you a set difference of what's not being provided. So this is very like a very simple operation that takes two lists, shakes them down, and just shows you the difference. And now you still have to do the work of trying to figure out how you ended up with an extra dependency that you're that you're not satisfying, but at the very least, you don't get the noisy, ugly type mismatch error. Now, if you really need the type mismatch error, and I'm thinking that I might, during the early stages of this plugin, make it a default, I added an option that you can also print out the original error if you want. So just in case this is too simplified for you, you could also get the original error back. And finally, this also works. I also did this for the error and the return type. And so, for example, if I'm going to write something here that's going to cause another mismatch, then hopefully, I'm not sure if this is going to work, but there might be additional. Yeah, so I'm also formatting the error type mismatch and the return type mismatch, but in this similar way. I'm saying you're stating you're requiring a string in the error type, but you gave me something that's serializable. So again, this is something that instead of getting this, because this is the original error message, you will get something like this, and it might bring you closer to solving the actual issue that you're having. One last thing that I want to show, and this is something that's actually I was inspired pretty much. I figured out how Enzyme does this, and the thing is that while this has to be a compiler plugin because I actually need to intercept the error message, it does not have to be installed directly in the project. One of the things that I discovered that Enzyme does, and I of course borrowed heavily from, is that Enzyme does clever SBT tricks, allowing you to install this compiler plugin as a global SBT plugin. So now if you go to the source code, you have to check the source code out, and then you type SBT install. What will happen is this is going to do a couple of things, but it's going to compile the jar for the plugin and put it somewhere in the user's cache directory right here. All right, for the for the library caches, and then it's going to install this ZIO plugin.scala file into the global plugins directory. And what this does, other than being extremely cool, is that it will allow the plugin to be available to all the projects that you are going to load with SBT or BSP in your system. So essentially, this is now a global plugin that's available for any Scala project. You don't have to do anything. And I think as something that can be installed as a tool, this is really, really nice. Well, it's a manual user experience, but this could be a really nice user experience to have something like a globally available helper for you to do guided, maybe guided ZIO projects, because I believe this could be further enhanced to do many other different things. Okay, so I'm going to stop for a second and ask if there are any questions so far or other type of feedback before showing you how this actually works.
So there's one question about, does this support Scala 3 also? I know you're doing Scala 2. But
Great question. So as of this moment, it still does not, simply because I have not yet implemented the class I'm going to show you for Scala 3. But it does work for Scala 3. It also works for both ZIO 1 and ZIO 2, because it just tries to find type mismatches. At this very moment, because it's a very early, like it started as a hack, this only works for errors that are of type ZIO. So this will ZIO and I think Z layers. So other type aliases might not work, but I have ideas on how to fix that as well. But yes, Scala 3 support should be coming like in momentarily, as far as I'm concerned, because let me just jump straight to the source code of the project. And this is it. It's available on GitHub. You can go and check it out. The license is Apache. And so it is essentially two files. The first file, the plugin file, is the file that you have to implement whenever you create a compiler plugin. You create a class called plugin that extends plugins, plugins coming from Scala tools, whatever. All right. Then you have some metadata here. You have some XMLs in the resources where you have to specify the entry point. This is how SBT will pick this up as a plugin. All right. Then you have to provide the description and the name. And finally, because this is a very thin plugin that does not modify any compilation steps, it does nothing. Then what I'm simply doing is replacing the global reporter. So there's this namespace called global, there's this object called global, and it exposes something that's called the reporter. And the reporter is an interface. If I'll navigate, this is a filtering reporter because it omits duplicates or omits, it can, never mind, it can do additional filtering if required. But this is a class reporter, which has some functionality reporting errors in the specified severity, allowing you to suppress stuff. So my plugin, all it does is implementing a new reporter, giving it the original underlying reporter to delegate the errors to, just in case I cannot match something with a regular expression, because it's all regular expressions underneath, because all I have are strings. I don't have any typed information. I don't have the AST. I don't have any additional thing other than the error message, and I have to work with that. So just strings, all right? And so this is kind of the heart of this. This is nicely formatted text, essentially. What I do is in this function called doReport, I am given the following things. I am giving the position in the source file, which are just the coordinates where the error is being shown. This is provided to me by the reporter. I get the actual string, the raw string of the error message, and I get the severity, which is an enum. I do a simple pattern match, just in case it's an error, and it's a ZIO type mismatch. I'm using a Scala extractor here just to conveniently hide all of this regex work. And this is the actual regex string I'm using.
Which we can see it works with ZIO or Z layer.
Yeah, right now it's just hard coded to ZIO or Z layer, and I got helped by ChatGPT writing this because I needed
it's got the
because of some de-aliasing. I needed to ignore nested brackets and stuff like that. But with my tests, this was good enough. And so what I do is I simply match on this, and then I do additional unapplies to try and extract the required and the found lists of all the dependencies. What I do with those strings is that I split them by the with keyword surrounded by spaces, because it will give me the entire cake. The type will be one giant cake. So I split it by this. I have to normalize the strings that I'm given, because Scala does additional, sometimes unnecessary de-aliasing of nested aliases. So I had one case where there was a type that had to do with Transact.io, the database library that we use. It was a Transact.io of task, and task is a ZIO task, but it ended up looking like this for some reason. So here I'm just normalizing it. I'm saying every time Scala shows you this is actually an alias of ZIO task. And I might add additional aliases in the end. But finally, after all of this string transformation happening, I end up doing this. I'm saying all errors are env mismatch errors, error type mismatch errors, return type mismatch errors, and optionally the original message if I specified in the parameters. I do a title, and I'm using the ANSI formatting that I borrowed from ZIO, just extension methods and strings that will format the text nicely. And then I'm just printing all of the errors, and all of the errors essentially are set operations on strings. So what I end up doing, all of these regular expression information extracts a set of strings for the R, and E and A are just strings right now. So I'm doing the found minus the required and minus any, because of course corner cases, but whatever's left is probably what you forgot to provide. And this actually worked. And I was so happy that it worked. And I let my colleagues to try it out, and they were extremely happy, because although we're trying to minimize the times, we'll try to minimize the number of times the type mismatch errors happen, when they still happen, they were able to much quickly figure out what the problem was without having to call me or require scanning manually for the errors. And actually, we actually found additional tricks how to do. You can actually use this to generate the entire requirement list. So you just say that your type expects like a layer of, like it takes a layer of unit or something like that. And it will tell you, oh, you're not providing all of these things. So you can take all of these things and make it an environment. But essentially, this is it. So one class, the reporter, which is currently being overridden here in the init function, where I also borrowed the knobs functionality, just the additional settings. I borrowed this from Better Monadic 4. This is how they do it. So like I said, everything stands on the shoulders of giants. And that's it. The only reason this still does not support Scala 3 is just because I haven't put anything in here. There's just, it looks slightly differently in Scala 3, but it's literally a matter of placing two files in here and just releasing it. And that's it. And as far as ZIO Clippy, this is it. This is something very simple. Now, before again starting, going to the questions or maybe talking a little bit about other stuff, I wanted to again thank Sam Halliday for the work, because I based all of my findings on his work, and also this is something that could be a beginning in my mind. This could be something much more maybe than just error reporting interceptor, because just as an idea, all right, this probably being a compiler plugin, all right, this could be used, for example, to modify the class path. So what if, just as a random idea, what if this could be the entry point to setting up a ZIO project from scratch, so that you would not need to start with adding a library or a library dependency into your SVT, but you could just have a globally enabled ZIO thing that would automatically pull the correct thing from the internet, from Maven, and set it up for you, putting the correct things in the class path. Just as an idea. Okay.
That would be very cool.
That would be very cool, and might potentially lead to more guided, like wizard-like experiences for people who want to get started and maybe not knowing exactly where to go to. So I will stop sharing my screen for this moment, and I would be happy if there's any additional questions or anything else that anybody would like to know. Thank you.
Yeah, that was awesome. Well, I mean, one thing I think I would just want to emphasize is, you kind of went straight to the environment and kind of dipping the environment there, and then went back to the errors and the value type. But I think just knowing which of those types is the one that has the error is really valuable, because a lot of times, you'll do the like found XYZ, required ABC, and it's not necessarily even clear, is the problem in the environment, is the problem in the error, is the problem in the value? Because like in your example, maybe it's like, well, it's a string and string, so obviously they're the same. But sometimes you have like, well, we found the serialization error, we expected a domain error. And you've kind of got to do the math in your head of like, is a serialization error a subtype of a domain error? Or is it not? And is it like covariant, so that's okay? Or is it contravariant, so that's not okay? It needs the other way around.
Right. This is a fantastic observation, because I actually thought about this and encountered this, but I would like to emphasize that this only happens in case of Scala failing to compile it. So in case of like a variance issue or of a subtyping issue, you most likely will not hit a type mismatch. So if you're declaring something, like if you're declaring exception, but you're failing with an IO exception, this will continue compiling just fine. But in case of an actual type mismatch, like for example, in case of an exception is serializable, you will not be able to pass go. You will be met with a compilation error. And again, this is helpful, trying to figure out why serializable will return. In fact, this is what we again have at work. We have our own domain error hierarchy. The company is called Unit, so our base error models,
which created its own errors for you at one point, I remember.
Yeah, yes, it had. Yes, it had. That's an anecdote for another day. But we have all kinds of errors, including we created one for wrapping throwables. So we have one that's called a throwable error that just takes any throwable as a parameter, as an argument, but it also our domain error. So like for interfacing with third parties. So for example, our most common case of something not something returning as serializable instead of our domain error is somebody forgot to wrap an actual throwable, which is a very nice indication of again, somebody forgot to do their well, not their job, but somebody forgot to check the result or wrap a third party API correctly, which again helps us. But you don't want to be met with a big ugly type mismatch error, and I think in this case this is going to be a much nicer experience. So this is a V0.01. This is the very first release of anything of this thing. I would be happy. I already got a report that it doesn't pick up on some cases, and in fact, I actually need a functionality where you can specify your own probably type aliases. So I don't want to hard code it to ZIO, because for example, at work we're using a ZIO-like framework. Or rather, where we have implemented our own kind of ZIO for the purposes of distributed computing. We called it Saga. It also has 3 type parameters. So it very much looks like ZIO, except it's called something else. And we also have these things where we need environments and stuff like that. So instead of hard coding our specific things into an open source project, I will probably make it, I will again borrow an idea from Sam, and there's a way to do this probably with an external mapping file. So it's like a resource that you can place in your project, or maybe in a global cache directory, so you could just load it on initialization and just read the mapping from there. So a lot of ideas in the space, and this is something we briefly touched on this at the beginning. This is something that I particularly enjoy doing, and I've been doing for a very long time, even before coming to Scala. This notion of improving developer productivity is one thing, but I always loved the idea of plugins. I always loved the idea of taking a system that may or may not be extendable out of the box and trying to find my way in, trying to override enough things with private reflection to be able to be considered a part of this ecosystem. This is I contributed some test running for Bazel, the Google's build system. It did not support Scala initially out of the box. And in my previous work, we not only used Scala, but we also used a very specific testing framework, Specs2, for running our tests. And Bazel did not support that. So I had to trick Bazel to pick it up and considering it like a JUnit runner, so that it would be able to work. Yeah. A lot of reflection. This was an amazing hack. And it ended up working, so I'm extremely proud of that accomplishment. But yeah, so that's it. So that's basically it for ZIO Clippy. The name Clippy just came about. It turns out that there's a similarly named project in the Rust ecosystem. I didn't know until somebody pointed that out. Clippy is, of course, we all know, is the helper, the helping Microsoft paperclip. I think now with the advance of AI, it actually might be due for a resurgence, because it actually might be helpful this time around.
Clippy reincarnated, yeah.
Yes. So I name my Clippy because it tries to be helpful. But silly name aside, I think this is a functionality which I wish could be baked into the library. And actually, this is actually what I wanted to ask you. In ZIO2, as I saw, if you have a type mismatch at the run method for the ZIO app default, right? Yeah. It will give you a nicely formatted list of dependencies that are missing. How is that actually working? Because that sounds to me like it should be a type error, a type mismatch error, but then I am getting something from a macro probably.
Yeah, it's from one of Kit's fancy macros, so we could dig into that sometime. But yeah, there may be more stuff we can leverage there. Sure. Yeah, it's really interesting because I mean I agree, it would be amazing if this was kind of actually built in versus like just kind of something had to be added on top. But there's also like interesting like path dependence. I remember when Kit started working on the automatic layer construction. Kind of his story about like how he got inspired to do that was he was working at his previous company with his coworkers. I think he was kind of filling a similar role that you are, of kind of being the Scala expert and trying to mentor other people. And they would be doing something and putting together these layers, and they'd be getting these error messages that were a complete disaster. And he was doing exactly the same thing of doing the manual diffing on them, which is terrible. And so then kind of the solution he came up with was, well, let's just automatically construct all of these layers together, which I mean is a great thing itself. But you almost wonder, like back in the day, like if at the time it was just like, hey, dude, you're missing B, you need to provide B. Like, maybe things would have gone a different way. I mean, I think they ended up going a really good way as is. But like all of these things kind of relate to each other. So if you like don't have a solution at one level, you kind of maybe go in a different direction at another level.
Right. No, and I've been a fan of that work early on, and I'm very happy it ended up being a part of ZIO2. And in fact, this is something we're looking. I mean, ZIO2 has been out for a while now, but for us, it's a slow, gradual project because the process of moving, because we do have lots of lines of code already written in ZIO1, and ScalaFix did a great job initially, but there are still some manual things that we need to do, and just the user experience that I've seen from, for example, the tests telling you which dependencies are missing, and just the main app itself. There are very few. There are significantly fewer places where I've seen type mismatch errors happening in ZIO2, and I'm very happy about that. In addition, maybe as an anecdote, the reason we might have more, or the reason we have type mismatch errors in the first place, maybe more than others, is that we deliberately do not specify the type signature almost anywhere. We let the compiler do the type inference for us, and most of the time it does the right thing, except for the weird cases of subtyping where we have to, for example, for Z layers, we have to specify the last thing to be the interface, the trait, because otherwise, I think there used to be like a widen or narrow thing early on, but I think that was removed. So we actually, the only type signature that we have is in the Z layer itself. The rest of it, other than the trait definition, is almost always omitted. So it's like def create, takes some arguments, equals, and then the body of the function. There is no return type mentioned. And so for the most part, it works great, except for when somebody inside forgets to do the right thing, and then you get the type mismatch error. And when that happens, by the way, we'll leverage the tooling again. So for example, in that case, I would generate temporarily, the type signature as the IDE believes it to be, all right? Then I would manually correct it to what I actually need it to be, to what I expect it to be at this point. And then the IDE will pinpoint me the line usually where this type mismatch actually happens. So in many cases, this is the error type mismatch, where we get a serializable instead of a throwable or something like that. But sometimes it's other things. And so when we're done fixing whatever, when it compiles, we just remove the type signature again. And this allows you for much more rapid development style. So for example, I use BSP personally even with IntelliJ. I use BSP simply because it has this amazing feature of compile and save, which is how VS Code works with Blue.
Yeah.
But the compile and save allows you to actually trigger the real compilation. And this is a major criticism of IntelliJ, is that what you see on the screen is not necessarily what the compiler currently believes it to be. There's a benefit to this. This is a topic for another conversation, another day. But having both worlds, so I can just hit save and it will immediately compile just whatever is changed. So I get a much faster feedback. And with BSP, it's perceived to be faster than SPT because it doesn't have to launch another process or talk to a compilation server in the backend. It's just using a protocol. So this is why I prefer BSP. It does have its own things sometimes where you have to massage it, but it's for the 95% of the time it serves us well. So why not?
Yeah, I think that's a really good point you raised in terms of kind of code style of how much you type or don't type things. I think Kit was a fan of a similar style of, in a way, I'd call it a little bit almost dynamic typing within a statically typed language of kind of don't include method signatures for a bunch of things. And obviously, if something doesn't fit together, the compiler will tell you, but it can kind of let you refactor a little more aggressively, because as long as kind of things still fit together, it works, versus kind of updating every method signature. I think I'm probably a little bit more like old school of like, I really like, before I even implement the method, I like, here's what takes in,
exactly.
Here's what returns.
I
know exactly the contract.
I was at the same kind of, I had the same school. I got convinced in the end that the friction, the sometimes the friction that happened was just not worth it. I had to, because of the style where we used heavily the environment a lot, I would have to repeat myself at almost every implementation point. And then it became no different than using other methods of context propagation. So we kind of left everything. And one of the nice benefits, especially when we switched to using ZIO Magic internally and now considering ZIO2, is that when you introduce new dependencies somewhere it leaves,
it just flows through everywhere.
It will just flows everywhere, and you will get the compilation error at the right point. You will get it in the main app saying you forgot to provide me a global dependency that's this. You just add one line. It's an amazing thing to experience.
So, and I think it may also be a thing where there may be some different trade-offs for like application code versus library code. But I think it's a really good thing to raise, because I think people may unintentionally, kind of without thinking about it, be doing it one way or the other, maybe typing everything. And like, at least I don't want to advocate here, like always do one way or always do the other, but more like be aware that there are kind of these like this continuum of different styles, and think about which is the one for just your code or your team or your organization, because I think they do have pluses and minuses. So I think that's a cool, like, not Clippy related, but kind of good point you raised.
Great. So fantastic. So I think we could wrap this up. Before we do, though, I did see one question that Adrian asked, is what happens right now. I split by the with keyword. So what happens in Scala 3? So actually, this is interesting, because if I may share my screen once more for just 1 second, there's actually nothing to show, but I did want to mention that we use internally at work. Let me see if I can just. We use the X source 3 flag for Scala 2. And this allows, they backported some of the syntax, allowing you to have better compatibility with Scala 3. So you could use the Enzyme today with Scala 2. Okay, you could do that. The error message, however, and this is kind of to answer, the error message in Scala 2 will always show you the with keyword. This is how they present, regardless of how you actually type it here manually.
So I think it's basically just an alias.
This worked in my favor. I will make sure that in Scala 3 I am getting the ampersands instead, and I will adjust I will refactor my my regexes accordingly. But yeah, so just to answer, even in Scala 2, if you use with, you will always, even if you use ampersand in Scala 2, you will always get with. I do need to see what Scala 3 does, but I'm sure it's manageable. All right.
Fantastic. Well, I think that covers the questions people had, but maybe just if you haven't already done so, in the Discord after this, you could paste a link just to where people can go to like see the project and download this, or how they could get involved if they want to. But I think this is like really cool stuff. And I think you raised a bunch of other things that maybe would be fun to talk about another time. I mean, I think one is just like, I think we could probably do a whole one of these and do a deep dive on ZIO IntelliJ and kind of everything in there, because there's a lot of functionality in there. And then a little bit, maybe less ZIO related, but I think probably a lot of people would benefit from your knowledge about just different IDEs to use and kind of how to use them most effectively and their advantages and disadvantages. Because I think like for a long time, the landscape was kind of, you had VS Code, which was buggy, but used the Scala compiler. And then you had kind of IntelliJ, which was more full featured, I would say more stable, but like didn't use the Scala compiler. And I think that's a more complicated story now with like the ability to use BSP with IntelliJ. And there's also kind of different Scala 3 stories. So yeah, I think sometime
that's fantastic. I would be more than happy to, because this is something I feel that I because I've been involved with this ecosystem for a while, I feel like I have a much greater appreciation about these things than it appears on the surface. So anytime.
Awesome. Well, it's always a pleasure talking to you. It's been a pleasure kind of getting to know you and working with you throughout the whole, I guess, my time with ZIO. So thank you so much for joining us, and have a great weekend, and have a great weekend to everyone else out there.
Thank you very much.
Bye, everyone.
Bye-bye.